In this video, we're going to talk about surveys and sampling. This will provide you with an overview of some key aspects to proper collecting of data so that your analysis will be valid. There are two sources of data: primary, and you want to guess the second one? Secondary. With primary data, that's data that we collect ourselves or yourself. In business, this is often done with a survey to gain insights about your customer or potential customer preferences. It can also be collected from experiments or observations, as you might encounter with a focus group. Secondary data is data that someone else has collected, and you're going to analyze it. This could be from a business or academic journal. It could also be from a well-recognized website like BPET.STATx, which I find to be very handy. There are, of course, trade-offs. We usually prefer primary data because we can control our point of view, but can also be very costly to collect. My tagline for secondary data is consider the source. Let's think about surveys for a moment. When we take a sample from our desired population, then we ask the people in the sample questions on a survey. We take that data that we collect to make inferences about an entire population that we don't know a lot about. That's why we're taking the survey in the first place, to try and find out what's going on with this large unknown population. And to do that, we need to take a sample. So let's start with a convenience sample, which you can see on the slide is under non-probability. Most of you have probably encountered a convenience sample either from the survey taker or survey respondent end. Here, one might ask family and friends their opinions because it's convenient and not very costly. This is not a good way to take a sample. It usually leads to biased and not very representative data, and therefore poor information. The key to good sampling is to get a random sample. To do that, one needs a population frame. Think about a population frame as a list of all the people in our target market population. From that, we want to draw a simple random sample. We first assign a number from 1 to the first person in the list down to big N, which is the number of people in our population, for each person in that frame. So 1, 2, 3, 4, up to 10,000, 100,000, whatever it is. Then we can use a variety of software tools, or even a random number table from a textbook if necessary, to select those individuals that will make up our sample. Now, I won't go into how big the sample should be, but there are some easy tools in some of the readings that will help you determine that number. And it often depends on how much money you have to spend. I also want to mention something called a stratified random sample. Here, we divide our population into subgroups like genders or regions in a geographic area, and that helps us ensure that we get adequate representation from each subgroup. After we split that population into respective subgroups, we then take really what essentially is a simple random sample from each one as if it was its own population frame. So the final aspect to sampling is recognition that there are survey errors that could be made. I'm going to talk about 4, and you can see them on the slide. The first one is something called a coverage or selection bias error. Here we may choose a population frame that really doesn't represent our desired population, and that will lead to biased results. I know many of you have encountered this, the non-response. Here we want to recognize that some people do not like to be surveyed and will not respond, or worse, give us answers that do not reflect their preferences. The third survey error is measurement. This can result to poor survey design, or respondent error, or data input errors. What you see now and today is technology can be a great help to reduce these types of errors. And then finally, a sampling error. Keeping in mind that we are working with a smaller sample from a very large population, it's entirely possible that our sample does not accurately reflect our population by simple random chance. even though we've done everything right in terms of our sample, our survey, and our data recording. Several years ago, the University of North Carolina did a survey of recent graduates to see how their earning potential was going. They did everything right, but their sample mean looked way too high. Upon further inspection, they discovered that just by simple random chance, they captured Michael Jordan, one of the best and most highly paid athletes in recent history, by pure random chance. So in summary, if you keep these guidelines and principles mentioned in this video in mind, you will greatly enhance the quality of the data that you collect and thus the validity of results, findings, and insights that can be derived from the data. Thank you.